Captions in English, please. So this is the second video of chapter 6, and that's going to introduce the chemical equation. So we've seen examples of chemical reactions, and so the way we represent them is by using chemical equations. For example, the reaction that was able to send the shuttle into space can be written like this. Oxygen gas plus hydrogen gas react together to form water. So we use an arrow to show the change, the chemical change or the chemical reaction. On the left side, we write what we call reactant. And so that's the starting materials. And then on the right side, we write the product. That's the ending materials. And so a chemical reaction involves the rearrangement in the way atoms are grouped or connected. You know, the bonds change. You break bonds and you form new bonds. However, atoms are conserved before and after a chemical reaction occurs. You have the same number of atoms of each kind on the reactant side and on the product side. This is the law of conservation of mass that implies that we need to make sure atoms are conserved. So let's look at another example. Carbon plus oxygen gives carbon dioxide. Written as chemical symbols, this becomes C plus O2 because oxygen is a diatomic molecule that is found as a two oxygen atoms bonded together in nature. So that's what we call elemental oxygen. So O2 gives CO2 because carbon dioxide is made of 1 carbon and 2 oxygen according to the name. That's type 3 covalent compound. So let's count the number of atoms of each kind on both sides. So on the left side, we have 1 carbon, and on the right side, 1 carbon. On the left side, we have 2 oxygen atoms in the diatomic molecule of oxygen. And on the right side, we have 2 oxygen atoms in the carbon dioxide. So because we have the same number of atoms on both sides of the arrow, we say that this reaction is balanced. All atoms are accounted for on both sides of the arrow. And so it satisfies the law of conservation of mass because we have the same number of atoms of each kind on both sides. Let's go through an example. We have CH4 plus O2 gives CO2 plus H2O. Let's count the number of atoms of each kind on both sides. So left side we have 1 carbon, right side 1 carbon in CO2. On the left side we have 4 hydrogens in the CH4 molecule and 2 hydrogens in the water molecule on the right side. On the left side we have 2 oxygens from the O2 molecule, and then on the right side we have 2 oxygens in CO2 plus 1 oxygen in water. That's 2 plus 1 is 3 oxygen, total number of oxygen atoms on the right side. So we can see that the hydrogens are not balanced. We have 4 hydrogens on the left, 2 on the right. Same with oxygen. We have 2 oxygens on the left, 3 on the right. So they are not balanced. So we will need to balance them. The number of hydrogen atoms needs to be balanced. And when writing or balancing a chemical reaction, you are only allowed to change the coefficients, not the subscript. So the coefficients are numbers we place in front of the chemical formulas of the reactant and product. They are placed in front, and you're not allowed to change the subscript of the formula. You cannot change the formula. Once you have the what we call the skeletal equation, like we have here, you cannot change the subscript and change the the formula of the compound or elements. You can only place new numbers that we call coefficients in front of the formula. So here, by placing a coefficient of 2 in front of the water, this will allow us to balance the hydrogen atoms. because by having 2 molecules of water instead of just 1, you multiply the coefficient by the subscript of 2 for the hydrogen, and 2 times 2 is 4. So we will have now 4 hydrogens on the right side. However, when you place a coefficient in front of a formula, it applies to all the elements that are in that formula. And so that means it will change the count of oxygen in the right side here. And we will have 2 molecules of water with 1 oxygen each. So that's going to be two oxygen atoms from the molecules of water plus 2 from the carbon dioxide. And instead of 3, now we have 4 oxygen atoms on the right side. So we can see that hydrogens are balanced, but now oxygens are not balanced. And so we need to balance the oxygens now. So the oxygen atoms are balanced by placing a coefficient of 2 in front of the oxygen molecules on the reactant side, because we have 4 oxygen atoms on the right side and only 2 on the left side. So we want to make it the same number. And so by having a coefficient of 2 in front of O2, this will allow us to have 4 oxygen atoms on the left side, because you multiply the coefficient by the subscript of 2. 2 times 2 is 4. So that's going to be 4 oxygen atoms on the left side now. And we can see now that the equation is balanced, because we have the same number of atoms of each kind on both sides of the arrow. So the equation will stay like this: 1 CH4 plus 2 oxygen molecule gives 1 molecule of carbon dioxide and 2 molecules of water. So when you are balancing a chemical reaction, you need to have the lowest possible coefficients. The coefficients should be the lowest possible. And so in the example on top here, we have 2 carbons plus 2 molecules of oxygen gives 2 carbon dioxide molecules. We see that we have 3 coefficients of 2. And so we could divide all these 2 by 2. And so the final balanced equation should be 1 carbon plus 1 oxygen molecule gives 1 carbon dioxide molecule. Coefficients of 1 are implied, and you've seen that the ones are often implied in chemistry. And here again, the coefficients, when they are 1, they are implied and usually not shown. So then the final version of this equation would be 1 carbon plus oxygen gives 1 molecule of CO2 with the ones omitted. So you need to specify the state of matter in the chemical equation to be complete. So we often specify the state of matter of each reactant and product in parentheses next to their formula. So these are the abbreviations that are used given the different states. So G is for gas, L for liquid, S for solid, and AQ for aqueous. So aqueous, so the AQ stands for aqueous, which indicates that a substance is dissolved in water. An aqueous solution is a solution where you have water as the solvent and you have, other substances dissolved in it. So, and when a substance dissolves in water, we call the mixture a solution. So aqueous solutions are made of water as the solvent, and you have substances dissolved in them. So in the example we had earlier, where carbon was reacting with oxygen and making 1 molecule of carbon dioxide, if we complete that with the state of matter, then we would have S after the carbon to show it's solid carbon plus oxygen gas, G is for gas, gives the carbon dioxide molecule is also gaseous at room temperature.